Yeah, thanks, Brad. And I'll just note that I'm not going to give two separate presentations. I'm going to give one continuous presentation before handing over to my colleague, Settle Bhakta, who's also from our Exploration Systems Development Mission Directorate. And he'll talk a little bit more specifically about the architecture concept review and our strategy for how we're developing and making architecture decisions right now. So I'll talk a little bit more focused on how the science is integrated into the architecture. So you just heard from Dr. Noah about all the cool stuff we know and how we're using that to help us make decisions about the architecture is important. I also just want to start out. I mean, I heard Noah mention this too. I'm looking at the participant list. It's up over 250 now. This is just wonderful. And I really want to stress, how important these workshops are. This workshop in particular is a conversation point with the community to help understand what we think we will need from surface elements as we start thinking about actually living on the moon for longer periods of time. And so I really, I'm looking at this list, and I hope that there are a significant number of early career folks on this list as well. Some people know this, maybe some don't, but Dr. Noah and myself were office mates in our early infant career or stage of our career before we got onto separate pathways. And so, for the early career folks online, you just never know, who you're going to work with, where you're going to end up. And we really do need to take into account the perspectives from the folks who are going to be doing this work 40 years from now, 30 years from now. And so again, a challenge maybe to some of our more senior members who are online, please do ensure that your early career folks are tied into this. These workshops really are a way for us to sort of set a standard, some traceability, if you will, to help us make the decisions that we'll be making over the next years. So I'll go to the next slide. Many of you may have seen this slide before, so I apologize if I seem extremely redundant to you. But for those who haven't, I do want to just note that we talk about three pillars that really hold up the value of our exploration. So why do we explore? Two of those pillars are inspiration and national posture. If I had more time, I would wax poetic about the value of those two pillars because they are extremely important. I just talked a little bit, I hope, about the inspiration pillar. We need folks to be doing this work after we're done. And the national posture is important. It's how we position ourselves to partner globally to develop this, because we have learned over the last decades that space exploration is hard. And if we're doing it alone, it's even harder. So this is really meant to be a point of partnership as we grow and develop those global partnerships. But science is also one of these three pillars. And I like to talk about the science circle in kind of two pieces. Maybe the piece that's outside the Venn diagram overlap and the section that's inside that Venn diagram overlap. Noah touched a little bit about this as well. But there's the science we want to go do. And that's what we're trying to understand now is what do we need to build into our systems so that we can go do that new science, learn the new things. But there's also the science that we've already learned. There's the knowledge we've already gained. And that's really the backbone around which we build this architecture. That understanding that Noah just described extremely well is the basis for us to make these decisions that we're making now so we can go learn more so we can make better decisions going forward. And so it's really important to understand that science, I say this to our engineers all the time, it's not just stuff we want to do somewhere down the road. That science is fully integrated into the decisions we're making now because it's the basis of the knowledge that we currently possess. Next slide, please. So with that in mind, we've gone through a little bit of a paradigm shift over the last handful of years. And we like to joke our human exploration orgs have gone through a number of reorgs. But really those reorgs were for a purpose. We're trying to structure ourselves in a way to meet this challenge that we've been given now. It's not just staying in low Earth orbit. It's not only going to the moon a few times and coming home. It's really about learning how to live and survive in space so we can go out and expand humankind and do the type of scientific research that we want. And so what we like to say now is that we're kind of turning things around into an objective-based approach. We want to be resilient and think strategically and be flexible, because this is not a single mission. This is a campaign of missions, of robotic missions, of crewed missions. And so we need to be flexible and resilient to handle changes over time. We're talking about these global partnerships, but politics change, objectives may evolve and change as we learn. And so we need a system, an architecture, if you will, that is able to tolerate some of those changes. And if we set the goal not necessarily on a single target, but on learning how to live and survive in space to go do that science, we can continue to evolve along with any of those changes. And so if we start more with a systems-based approach or a capabilities approach, we start to build things, and as those changes occur, we can lose touch with why they're there, and they might not even be able to address the specific needs that we have urgently at any given time. And so what we end up with as funding changes and objectives change and politics change in the past is a series of programs or elements that maybe don't necessarily coalesce as well as we need. And so that's what we're trying to evolve away from, into a system that really takes into account the objectives as the starting point so that we can continue to build and evolve from there. Next slide, please. Okay, next slide. Sorry, so what we've done over the last 2-3 years is build a list of objectives. These are owned at our NASA agency level. At the NASA level. So these are not objectives in our directorate or the Science Mission Directorate or the Space Ops or the Space Tech Directorates. It's the entire NASA community set of objectives. What we'll talk about a little bit over the next few slides is that this isn't a set of objectives that we went off and made up on our own at headquarters or at one of the centers. This has been a process of engaging the community broadly, both internationally and here at home in the United States, and trying to really understand what it is we want to do out there. I believe that if you look at this document, the QR code is in the bottom left, you will actually notice that it traces very well to much of the work that you all have done over the last years to decades in documenting things in decadals and in other places. So again, I really want to drive home the point that we're not just coming up with new objectives and hoping to sell you on them, right? We're looking to you, and that's the purpose of these workshops, is looking to the community to help us determine how to move forward. So again, objectives-based approach, we need to establish a constancy of purpose and a unity of purpose as we move through achieving those objectives. A really key point to this is enhanced communication and engagement. These workshops are an example of that, but we are beginning to publish our activities on a yearly basis, and Settle will talk a little bit more about this through what we call our architecture concept review. But again, that interaction is critical for us, again, to make sure we understand the community inputs and that we're accounting for the objectives that the community carries. Next slide, please. Okay, so those objectives break down into several areas, and I'll just show these here, and I wanted to make them available, but I do encourage you to go and dig into that documentation. It's really important to make sure you know what the objectives are that are written down so that you can understand what we are trying to trace to. But the first and most important thing in some cases is that we identified a set of what we call recurring tenets. These tenets are basically something that was present in all sets of objectives. And so they're kind of something that we consider to be, it's necessary to have there. So you can see some of these examples, but with crewed missions, we need crew time, right? We need the astronauts to have time to do some of the work to meet those objectives. If they spend all their time just fixing things and supporting the infrastructure, that's not the point. We need to develop an architecture and make choices now that enable them to do that. But you can see interoperability as we look to our industry partners to provide solutions. We have to make sure these systems work together. collaborating with industry, maintainability, reuse. You can read these as well as I can, and please do, again, dig into them. But the recurrent tenets are basically a thread that kind of is woven through all the sets of objectives. Next slide, please. There are sets of non-science, okay, we'll go into the science objectives. We have broken those down into several large areas, and I think you'll see these make fairly good sense for learning how to live away from the Earth. Lunar and planetary science, heliophysics science, human and biological science, physics and physical science. There are sets of science enabling objectives as well, and then applied science. So that's sort of that boundary into how we use the science to help make the decisions we want to make going forward. So I talked to many of these groups. Earlier this year, I talked with a space weather workshop, kind of highlighting how space weather and heliophysics ties in. But again, kind of all of these bins may have needs of surface habitation and conducting research in a habitable environment. And so that's what we're trying to tease out throughout this workshop going forward here. Next slide, please. There are exploration objectives in addition. So we have lunar infrastructure and Mars infrastructure. There are objectives related to transportation and habitation, as well as operations. So think about these, Brad was very eloquent at the beginning, speaking about the partnership here. So these are some of the objectives that maybe is not the science you want to do, but if we can't get there and we can't set up the supporting infrastructure, then we won't be in a position to do the science that you want. And so we have to take all of these objectives into account together as we design that architecture. Next slide, please. Architecture elements. So think about these as the vehicles, the programs. These are often assigned to programs at our NASA centers. But these are basically the pieces that make up the architecture. So I wanted to show a few examples here. And Brad mentioned a few of these as well at the beginning. Off to the left are some of the systems that are already in place. So Space Launch System and the Orion spacecraft are what we tested along with the comm systems and the ground systems when we flew Artemis 1. So we've demonstrated the ability to fly those systems, which puts us into a position where we can now start testing the next systems. So we're looking at landing systems, and we're looking at EVA systems, and we're looking at developing the gateway to be in orbit around the moon. Again, that's a habitable environment from which we may be able to conduct some of the research that you're interested in. And eventually, off to the right, then getting into a place where we have continued development of increased capability that will eventually lead to surface habitats, surface habitation. On our way there, where we are right now is kind of looking at surface mobility. We do understand that we can land and we can work on our precision with landing to get really close to where we want to be. But we also want to travel far around the lunar surface and expose ourselves to different terrains, different environments. So the types of things that Noah was talking about, all this unique attributes that the polar region has to provide to us, we need to be able to get to it. We can look at it from orbit, but we also would like to be able to get our robots and our people to those places to do that research as well. So I just wanted to mention kind of this continued development, and some of these are now some of our international contributions. I'll talk a little bit about the mobility ones going forward because I want to use them as an example to demonstrate how we're bringing the science on board. And that's, again, one of the things we're trying to do with this workshop is understand the science that you'd like to do so that we can make the right choices. Next slide, please. That said, we have conducted some science already. So Artemis 1 was a test of those elements that I mentioned already. But during the flight, we did conduct a good bit of research. Some of that research was conducted inside the Orion. So we had a series of sensors, and we had some mannequins that were meant to simulate what our crew will experience when they fly on Artemis 2, when we really test out the ECLS systems, the environmental control and life support systems of the Orion with our astronauts on board, providing them with the opportunity to take the first glimpse of the far side of the moon in over 50 years with human eyes. So again, these sensors were really meant in many cases to characterize and understand that environment, understand how biology responds to the environment that we're going to be expecting our systems and especially our friends to fly through in future Artemis missions. So we want to make sure that we have developed a safe approach, because the number one most important objective we carry is bringing our friends home on every mission. We also had a series of CubeSats that were flown, looking at how we take advantage of opportunities to deploy payloads throughout the transit to the moon. So we had varied levels of success of those CubeSats, but learning how to conduct science in this manner is something that's important so that we can do it in the future more dependably. Next slide, please. So Artemis 2, we now have our crew. You probably have seen some information about that, including a friend from Canada as well. So an international crew going out to the moon and orbiting the moon before coming home provides us with a great opportunity to conduct human research. We'll be conducting research on biology and physical sciences. And again, I already mentioned the first opportunity to have astronauts, human beings, our friends, take a look at the far side of the moon in over 50 years. So again, I want to drive home that this diverse set of objectives, right? We have objectives about learning how to fly these new elements, these new systems, making sure that our life support systems work properly. While we're doing that, we're coupling those with science objectives. Might not be the number one way we want to always go achieve these, but these are opportunities for us to do research. And as we grow and increase our capability, those opportunities will also grow and increase as well. But we need to know what you would like to do so we can grow those opportunities in the right way. Next slide, please. We're looking forward then to Artemis 3 when we will land on the surface. And I'm not going to go into any detail about this because I'm sure you'll hear a little bit more from our friends in SMD. I do want to drive home the point here, though, that I mentioned on the last slide, the opportunity to do science. In ESDMD, Exploration Systems Development, that's what we're trying to develop in the architectures, the opportunity for the science. We then look to our other mission directorate colleagues, in this case SMD, to identify how they would use those opportunities, use those utilization resources, those science resources. And a point I want to make here is I get asked all the time, how do I get my science on board? The way that you get your science on board is to look to the mission directorates that typically and traditionally fund the type of research that you do. So if you do research through SMD, you don't come to us in ESDMD to try and understand or find a way to get on board. The Science Mission Directorate is who we interact with, and they will be the ones who put out calls and identify the funding to take advantage of those opportunities to meet those objectives that I talked about at the beginning of this presentation. So again, start from the objectives, determine what capabilities we need to have in place, and then look to the directorates that you typically are funded by to fund the research that will enable you to do that work. And these are some examples of some of the recently selected payloads from SMD. Again, I'm not going to go into any detail with them because they're their payloads. Next slide, please. We have also identified initial payloads to fly on the Gateway. So the Gateway would be an orbiter around the moon, basically a research station that helps us learn about living away from the Earth. That's what helps us understand how to live longer and be on the surface longer at the moon, but also start thinking about how we go beyond the moon, exploring the solar system. These initial payloads on the first elements of the Gateway that will be in orbit, even before crew get there, are really focused, just like Artemis 1, on helping us understand the environment that our astronauts are going to be expected to survive in, as well as these systems that will be supporting them. So you can read through these, but ESA, European Space Agency, provided a radiation sensor array called ERSA. JAXA is providing some activities, including dosimeter arrays that would be internal to match with those measurements from outside. And then NASA's provided a heliophysics payload as well to couple and match with ERSA from ESA. So again, making these great measurements outside and inside the spacecraft to help us understand that environment so that we can think about the impact of biology to life, to our humans going forward. Next slide, please. I just used this slide to drive home. I talked about the global influence, the partnership. Well, we've got partnership from many different countries and companies right now in helping us to build that gateway. Next slide, please. And we got two quick examples about the mobility. Earlier this year, we announced 3 companies, Lunar Outpost, Intuitive Machines, and Venturi Astrolab, who will continue developing their concepts for the Lunar Terrain Vehicle. Lunar Terrain Vehicle is an unpressurized vehicle that will be our first mobility enhancement on the surface so that astronauts can ride on it and get to places they otherwise wouldn't be able to reach, as well as operate that vehicle when astronauts are not there. So we can use it more like a robot then to explore when the astronauts are here on Earth and not at the moon. Again, this generates opportunity for science. And that science, we look to our other directorates to define how they want to do that and take advantage of that. So we'll be looking to our other directorates to outfit these vehicles as we get closer to down selecting to 1 so that we can maximize the science we do from it. Next slide, please. In addition to the unpressurized vehicle, we're also in discussions with JAXA about providing a pressurized vehicle that would enable astronauts to live in basically a shirt sleeve environment and potentially reach additional locations they might not even be able to reach with the LTV, the unpressurized vehicle. So again, we're in the same stage here of trying to understand the needs, and this is a habitable volume here that the astronauts would have. So the discussion today will be very relevant for that. Next slide, please. With that, my part of the presentation is done. Again, I want to just drive home that point that we're starting from objectives and we're tracing through those objectives, understanding what we want to do to make informed decisions about how to build the architecture. I don't know, Brad, if you want to introduce Settle, I'll just say my colleague Settle Bakhta, I work really closely with him, and you know, he's going to talk a little bit now about how we actually try to make those decisions.